Okay, so that's session number 4. We have 3 talks. As you see, the first one is multitask benchmark for assessing Arabic legal knowledge in large language models. And we have Faris presenting it. Start.
All right, Bismillah. أولاً السلام عليكم. My name is Faris Hijazi. Today we're going to be presenting our work, ArabLegalEval, a multitask benchmark for assessing Arabic legal knowledge in LLMs. So I'm sure everyone has at least worked a little bit with LLMs and would like a better or more concrete way to quantify their performance. Our paper is going to be discussing that. This is a joint research between Thilka Company and KAUST, King Abdullah University for Science and Technology, and we're going to be having two main contributions. One is the benchmark dataset itself, which is a huge collection of questions and answers that will quantify and give an evaluation and somewhat a metric for the LLM performance. In this case, in the Arabic language and in the legal domain. So this is domain specific. The other thing is that the methodology that we use to create this data set. So these are applicable to any domain and any language, which is why the methodology is a contribution. We open source all our code and all our data, so feel free to check it. There will be a QR code at the very end. We'll be going over the introduction, current LLMs, why we decided to do this, why we decided to go with a benchmark, why we decided to go with legal, the legal landscape and the sources, the data sources, why we chose them, challenges with current LLMs, the data set and how it was created, and then excitingly results and comparing different LLMs. So why did we decide to go with this? Just like everyone, we decided to create our own LLM. So we head out and started testing different LLMs, different data sets, commercial, closed source, open source. And we realized quickly that it's actually not very easy to choose actually which one is performing better. We noticed recently with generative AI in general that it's a lot less about engineering and it's becoming a lot more about defining the problem. So it's getting a little bit fuzzy, which us engineers and scientists are not very comfortable with. So we always have to start by defining the problem and a metric that we're aiming for. So this is why we created a benchmark, and as many great scientists have mentioned, if you cannot measure it, you cannot improve it. So instead of investing our time into building an LLM, we invested time into creating a dataset and benchmark. And why the legal domain? Well, it's promising. It was quite exciting seeing that the GPT-4 has passed the bar exam, although there are some skeptics because it's a very narrow domain exam. And then it's challenging and impactful, so hopefully solving it will actually improve people's lives. We're hoping that. In terms of related works, so this presentation I'll just be talking about the dataset, why we created it. I'm just going to try to give as much context as possible. As I mentioned, I already explained our work. We created a dataset, and I'm going to be explaining how this is impactful for you and how you can benefit from this. So related works, this has been done in multiple languages. We have Legal Bench, which is a collection of 162 different tasks. Please do remember the name of this paper, Legal Bench. I will be referencing it many times. Most of these are closed set question answering, which means you either have a question or a document and a question, and then the answer is within a limited number of possible answers, like yes or no, relevant, not relevant. It's not free text output, which makes it very easy to evaluate. It's easy to regex yes or no. There's also the Mandarin and Chinese document equivalent, which is Law Bench. And then the Arabic MMLU actually has a subset of political and legal science, or sorry, legal and political science. Challenges with current Arabic LLMs, it's not a surprise that there are many dialects in the Arabic language, which creates different nuances according to different regions, different countries, and we have, Arabic is already not a very high resource language. In addition, anytime, whether it's Arabic or not, when we go into a specific domain, things get quite, the vocabulary can become quite scarce. All of the words already exist on the internet, but the usage of certain words within certain contexts, especially legal, becomes extremely scarce, so these base LLMs are not used to seeing these, which is one of the challenges. And then evaluation and measurement, this is not specific to Arabic or legal, just evaluating is difficult in general. All right, So going on, as we scour to find some data to create our benchmark, we are going to use open source public data and we scrape them. First, we consulted legal experts. What type of data is actually relevant? We want to kind of min-max or choose something that is low effort and extremely impactful. It turns out that within different domains, the top 3 are commercial law, public law, and civil law, which comprise of most law. I mean, you can imagine that commercial law is the majority. So based on this, we chose 2 data sources out of 38, which feed into these 3 domains. So just having these 2 data sources, which are raw documents, not questions and answers, just raw legislations and documents, will feed into this. Moving on, this is our distribution for our data set. We have these raw documents, and then we have a couple of other benchmarks which we'll either translate or use as seed data to synthetically generate more data. So from this data, we created 3 different formats of questions. We have open-ended question answering, where the LLM can speak freely, which is harder to evaluate, and we'll get to that later. And then we have multiple choice questions, which you are all familiar with, such as MMLU, where you have to choose A, B, C. And then you have legal bench, which I have mentioned before, the English legal benchmark. We translate it, and we talk about how we do the translation. So experiment setup, you'll be noticing this pattern quite a lot. We start with having raw data, we do a lot of experiments, we do filtration, and to save effort, we can't filter every single example with legal experts, it will be too expensive. That's why we create a funnel. First, we filter it automatically, we filter syntactically, we filter, and we just keep doing different prompting methods, this is all engineering, basically. I'm sure you're very familiar with the creating baselines. So we create multiple baselines, and we just perform evaluation on different baselines. And we end up with, at the very end, check with legal experts, and then we have our first part of our data set, which is the MCQs. We do prompt optimization during the inference time or during the benchmark time. No interesting insights here except 2 things. First of all, chain of thought in English has much higher performance than in Arabic. Even though the input and the output that is expected is in Arabic, you can see on the right side that Arabic chain of thought performs worse. This is consistent across all models. In addition, this is also actually interesting. The few shot examples that we use to optimize different LLMs, of course we optimize per LLM, and these few shot examples that give good results are consistent. The same few examples are consistent across every LLM, which just indicates that yes, it's not LLM specific, some examples just have very high signal. Moving on to our second task, which is the open-ended question answering. Once again, another funnel where we gather handwritten, frequently asked questions. We scrape these, and the work that we do is we compare them, we find raw documents that are the context for them. Here's an example, question, answer, context. And then we have the translated legal bench. This is our third task. These are closed set question answering. We choose data that is universal and not region specific, such as privacy policy. Am I allowed to use this data from the user? These are not specific to a specific country or specific language, and even when you translate them, it's not specific. We do a lot of work for translation. We evaluate using GPT-4, using root score metrics, using legal experts to review, and consistently, Opus machine translation achieves the best, so we use the Opus machine translation model to do the translation. This is the template that we use. Once again, English instructions, even though the content is in Arabic and the expected answer is in Arabic. Results, we do experimentation across multilingual and Arabic specific, as well as open source and closed source models. So first task, the MCQs, once again, multiple prompting methods, and it's not surprising that GPT-4o is performing the best. FewShot is the best performer. And then we have our legal expert. We actually had a small, very, very small sample. So this is one of the things that need to be improved in the paper. We had an absolutely tiny sample. We took it to our legal experts, and we compared them with the LLMs. So legal experts are 90% out of 100, and then you have the best LLM is around 80%. So it's reasonable to see this, that the experts, I'm hoping that the legal experts are going to do better. But the LLMs are not too far behind. And we also have to mention that these legal experts are not specialized in commercial law, which is most of our data. And then our second task is the open-ended question answering, which is difficult to evaluate because the LLM is free to continue speaking. So once again, and you've seen this today multiple times, we use GPT-4 as a judge, or a strong LLM as a judge, to give a rating given the ground truth answer. Is it matching or is it not matching? It's important to mention this, that LLM judges are biased towards their own answers. So what we have to do is, for example, use Cloud to evaluate GPT-4 and then GPT-4 to evaluate Cloud, just to make sure that we don't have any bias. And here, these red lines are the legal experts, and they are not performing better than the best LLMs. But we believe this is because of the small sample size and because of that they are not specialized within the data domain that we have. So we can see GPT-4 is performing the best. Once again, not surprising. Running across different times. Actually, sometimes Cloud is the best, and some Cloud 3 Opus, and sometimes I'm not going to go into every single detail. I'm just going to give you the observations that we have. That open source LLMs are not far behind. You can refer to the paper for more details. And then let's go to finally the translated legal bench. You can see that once again, open source models are not far behind. Usually Command R plus is the follow-up to GPT-4 in every single benchmark that we have. And here we can see that the LLMs are scarily close to our legal experts. Once again, it might be because they're not specialized within our domain data. Here are more details about each task. You can refer to the paper. Future work, as I mentioned before, we need to do more rigorous testing and more rigorous evaluation from legal experts that are actually specialized in the data that we're using. We should do more comprehensive runs across different LLMs. We did not get to run through every single LLM. And by the time we've published the paper, new LLMs have come out, like Llama 3.1 and other ones. And granular categorization of the data. We would love to do this. So some of our data, some questions require more context. For example, if I say, how many years does it need, does a driving license expire in Saudi Arabia? I would not expect an LLM to know this. However, I would expect an LLM to be able to answer this given the context. So it would be really helpful to have such a metadata tag within every single question so that we can start filtering these and be fair. Because what we noticed, this is also very helpful for RAG evaluation. And in our open-ended question answering, what we do is we feed it once. Sorry, I have to go back to this. We feed it once with context and once without context. So this is actually double the amount of the LLMs. And we thought with no context it would not be able to answer at all, but we can see that it's actually very close. Especially large models, they're able to answer without context at all. This data set specifically is also very helpful for evaluating the RAG itself, whether it's retrieving the correct context or not. And thank you very much for listening.